Welcome. In this video, let us understand the regulated DC power supply block diagram. Regulated DC power supply is used to provide a constant DC voltage irrespective of the input signal variations and the load variations. So it maintains constant output voltage even there are variation in the input voltage as well as the load. So the major components of this regulated DC power supply are transformer, rectifier, filter and regulator. So there are four major components: transformer, rectifier, filter and regulator. Now let us understand the function of all the four components, the purpose of transformer, rectifier, filter and regulator in the regulated DC power supply. The transformer is used for step down the input voltage or step up the input voltage. In most of the electronic circuit, that step down transformer is used, in which the input voltage is reduced to a required level. That means the secondary voltage is lesser than the primary. Step down transformer used in most of the electronic circuits where the input voltage is reduced to a required level. It may be 6 volts, 9 volts, 12 volts, 15 volts, 20 volts, 24 volts and so on. Our primary is normally connected to AC supply where you will get around 220 to 230 volts input. But for our electronic circuit you need lesser voltage. So step down transformer is used for reducing the input voltage. Step down transformer is used to reduce the input voltage to a required level. The voltage may be 6 volts, 9 volts, 12 volts, etc. Whereas step up transformer is used to increase input voltage. A step up transformer increases the input voltage. So normally step up transformer used in CRTs, cathode ray tubes. So where you require higher voltage, it may be more than 400 volts. In such cases they use step up transformer. So step down transformer will reduce the voltage to a required level. That means secondary voltage is lesser than the primary, whereas step up transformer increases the input voltage. Now let us consider the rectifier. Now let us consider the rectifier circuit. So the transformer signal, that is secondary signal, which is lesser compared to the primary signal. So the transformer signal secondary voltage is applied to the rectifier. So let us understand the function or purpose of the rectifier circuit. Rectifier circuit is used for converting AC into DC. Here the waveform is shown for full wave rectifier. Rectifier converts AC signal into DC signal. So the rectifier is a circuit used to convert AC signal into pulsating DC. Normally most of the circuits they use full wave rectifier. There are two rectifiers, one is half wave rectifier, another one is full wave rectifier. So half wave rectifier converts one of the half cycle into DC signal. It may be positive or negative based on the direction of the diode is connected, and full wave rectifier will convert both positive and negative half cycles into DC. Rectifier waveform is shown, which is Fourier rectifier output. The output of the rectifier is a pulsating DC, so it is not a pure DC. So the pulsating waveform indicates that it has got AC components also. So it is necessary to remove unwanted AC signals. For that purpose, we use filter. So filter is a circuit which is used to remove unwanted AC signal from the rectifier output. So filter circuit removes unwanted AC signal and it provides more DC. It's almost a pure DC output. Here pulsating output is there in the rectifier. Filter circuit removes AC components from the rectifier output and it gives almost a pure DC signal. The filter circuit used to remove unwanted AC variation from the rectifier output so that it provides a pure DC. Now let us consider the last block, that is regulator. Let us understand the function of regulator. The filter output, this is the filter output, is applied to the regulator. Regulator circuit is used to provide constant DC output voltage even there are changes in the input signal. So this is our input signal. Even there are changes in the input signal, this regulator maintains constant output, and also it maintains constant output even there are changes in the load. So the regulator circuit used to provide a constant DC output voltage even there are changes in the input signal or changes in the load. Now let us summarize the working of a regulated DC power supply. The AC input signal coming from the mains applied to the transformer. So normally it is a step down transformer which will reduce the voltage, input voltage into a required level. That means the transformer secondary voltage is lesser than the primary voltage. The transformer signal, secondary signal, is applied to the rectifier. Rectifier converts AC signal into DC signal, which provides pulsating DC, and this is the output waveform of Fourier rectifier. Rectifier output, which is pulsating waveform, indicates that it has got AC component along with the DC. Therefore, it is necessary to remove unwanted AC signal to get pure DC. For this purpose, we use filter circuit. The filter circuit removes unwanted AC signal and provides more DC, a pure DC signal. And the output of the filter circuit is applied to the regulator. The purpose of regulator is to maintain constant output voltage even there are changes in the input signal, in the AC input signal, and also the load variations. So the regulator purpose is to provide the constant output voltage even there are variations in the input signal or load.